Good morning, everybody. Welcome to a sunny Friday morning, October 1st, beginning of a new month. Yay! With Chem 1105 with your host, me, Dr. White. Now it's October 1st, so don't forget, there are only 30 more shopping days till Halloween. Well, I just thought of something sad. I'm going to pout. That is whenever for many years now, when I teach face-to-face before the pandemic, if I had a class that met on Halloween, that was always fun. Or if I didn't, and the first class after Halloween, like for you, if we were meeting face-to-face this year, I brought in candy. Now for at least 2 pieces for every student. Now I should tell you, I give out candy following my golden rule of Halloween candy. What's that? That's don't give candy to someone else that you wouldn't want yourself. So what that usually means is either depending on what I'm in the mood for in the last couple of years, it's been Kit Kat, the good stuff, or Nestle's Crunch, real good stuff. And that's what I give out. But I can't, but anyways, I would. All right, hold on. If I'm going to extend the deadline for the labs till Tuesday. One of the things, some personal stuff's going on in my life that I have to attend to. And on Wednesday, by the time I got through with that personal stuff I had to attend to, I'd missed my office hour, which is really rare. Actually, to tell you the truth, at COD, adjuncts are not required to have office hours, but I do because you're worth it. All right. So anyways, quick thing, I'm going to extend my deadline for any labs you haven't handed in until next Tuesday. Well, let's make it 5 p.m. That gives you plenty of time. Also, next Tuesday, I will go through Chapter 5, Part 1, problem set, the whole problem set. Now, I think I mentioned it, but test number 2 is usually the lowest average of the semester. Doesn't have to be. Last couple semesters, 2 of the classes, it was very high. One, well, it wasn't that very high. But if you do the practice problems on your own, you'll do good. All right, now, one other thing I have to talk about, and that is I haven't uploaded them yet. Sometime today or tomorrow I will. For those who handed it in, I graded in, I think it's lab 5, moving electrons. And the reason I'm going to talk to everybody about it, because some of you need the following, and that is someone to help you out as a mentor. Now, I was very lucky so far in my life. I've had a number of great mentors. One of the greatest, besides my PhD advisor, Dr. Roosh, was Sid Shapiro. When I first started out in industry, the chemical industry, I was in my late 20s. Sid was in his early 70s, great chemical engineer who was also a great chemist, probably one of the smartest people I've ever met in my life. And we actually carpooled for over a year until he got transferred downtown Chicago from our labs in McCook. And for an hour and a half, 45 minutes each day, 5 days a week for a year. And even before that, he was my mentor. He taught me a lot and quizzed me a lot. And it was an exciting ride both ways because I learned a lot. And I'm going to teach you some things. First of all, the one thing Sid pounded in my head over and over again, he used to say, common sense is not common, and it's not. And I don't know if today, if I, after class, for those who want to stick around, I'll tell you an interesting common sense story that I use common sense that other people didn't, that cost, until I got involved, the company over $500,000, and it shouldn't have. But anyways, what I'm talking about is lab number 5. I do my introduction for each lab. If we were face to face, I'd give you the same introduction that I let you start working in the lab. Guess what? I don't have to do that, but I do that to help you. You should pay attention. And if you miss anything, luckily, everything's on YouTube, so you can see it again. And use common sense. What do I mean? A lot of you got number 5 wrong, and I take off points for wrong questions. And what's the chemical reason? And I even gave you a hint, subatomic reason. And a lot of you went out on the internet, which there's a lot of good information on the internet to answer this question. Guess what? My introduction of what I write in the lab here, you should not have to go out into the internet. And I say, what causes colors in the fireworks? Hint, subatomic reason. The flame test dealt with, guess what? Colors. And their answer is electrons are moving from shell to shell. That's the reason fireworks, for various chemicals they put in there, have different colors. I give you everything you need to answer those questions in my introduction and in the lab. Common sense, which is not common. If I ask you for a subatomic reason, don't do something that's not subatomic. Now, let's do another one. Number 7, we're talking about the glow in the dark test. How did you make those paints glow? You expose them to UV light. How would you make it glow longer? Expose it longer to UV light. Now, the last one, which is, oh, come on, read questions and read them again. Number 8, what are the identities of unknown samples A and B? And also, what do I have underlined? Briefly explain how you know this using your data to justify your answer. It was simple. I had to look up and say, it was A was this because it was in the table I did in part 1. Same thing for B. It wasn't that hard, and a lot of you didn't. And I took off points. So use common sense. It's not common, but it's not hard to do. Think. Also read the questions. All right, I got that out of my system because I'll be honest with you, it doesn't make me happy taking points off on a lab. But if you put down wrong answers, I do. It shouldn't be that hard. But you got to use common sense, and common sense is not common. All right, let's go on back to chapter 5. And chapter 5, I think I've covered this in depth. When we have a balanced chemical equation and you're asked to go from grams of a reactant to grams of a product, or from grams of a product to grams of a reactant, you have to use this 3-step conversion. Step 1, convert mass grams of A to moles of A. Step 2, use the coefficients of the balanced chemical equation to convert moles of A to moles of B, and then take moles of B and convert it to mass of B. And we've done that. Go back and look at the videotapes. And remember, 1 mole of a compound equals its molecular weight, and the coefficient of balanced chemical equation represent molar quantities. And on Tuesday, when I go through chapter 5, part 1 practice problems for the test, we'll cover this again. But I highly urge you to do it on your own. All right, I haven't done this a while, but I'm gonna click the switch. Will this be on the test is in the off Yes, the off position, it won't be on the test or the final, but I do want to cover it. There's something called percent composition. And for a compound, there's ways of determining the percent mass of each element. And that's the mass of each element in grams from the atomic weight divided by the molar mass, the molecular weight of the compound, times 100. And this can be a very useful number to help identify or prove the existence of chemical compounds. For my PhD thesis, wow, that was a while ago. Ooh, don't think about it, Dr. White. But anyways, it was a joyous time in my life, though, very joyous. I created or synthesized, by the way, synthesize or synthesis is a fancy word meaning make or to make. I synthesized about 145 new compounds, and each one I had to calculate myself the percent mass for in organic chemistry, carbon, hydrogen, and oxygen, or carbon, hydrogen, nitrogen. And you also send out a sample, highly purified, actually 2 of them, to a lab. And we had a company our research group used that was very good. And they measure their devices that will measure percent analysis for carbon, hydrogen, and nitrogen. And when I got the results back for each group I sent out, checked them, and they were the same. And that was put in my thesis and also a publication in Tetrahedron, an international journal for organic chemistry coming out of England, that an article from my PhD research was published, and it had it in there. Anyways, that's CH analysis. And sometimes you'll see that used in the, what do they call it, the CSI program, CSI Miami, and they have New Orleans, whatever. I don't watch those because they're too hyped up. It's not real life, but they're close. All right. Well, in that case, guess what? We finished chapter 5. But before we go to the new chapter, I promised we'd go through balanced chemical equation problem set. And I had an idea. And I hope you'll like it. But first, let me close something. And I thought we'd do some practice problems together. And let me set it. All right. Thumbs up, people. Everybody see number 1, sodium plus chlorine Cl2 going to NaCl, sodium chloride, tablespoon. Thank you, Mackenzie. All right, balance it. Your turn. Oh, that was rough. But anyways, remember when you balance it, you can't change the chemical formula, but you can change the coefficients. Your turn. And when you're done, give me a thumbs up. Ooh, I forgot to mention something. Today's Friday, the last day of the week. And unfortunately, you won't be seeing me Saturday or Sunday. And if you're going through Dr. White withdrawal symptoms, always feel free to go to my Chem 1105 YouTube channel so you can watch me if you're undergoing Dr. White withdrawal symptoms. And happy Friday to you, Ruben. Or if you're Jewish tonight at sundown, you would say good Sabbath. That's the English version. There's Yiddish version. All right, let's assume everybody's done. And notice I have 1 sodium, 1 sodium, not bad. But I have 2 chlorine. I only have 1. How do I make that 2? Put a 2 there. I now have 2 chlorine, but I have 2 sodium. How do I get 2 sodium? Put a 2 there, and I have 2 sodium. And now I'm going to double check 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. We're balanced. Also make sure you can't divide all the coefficients by the same number and get a whole number. Like if you had written this, if you said, well, it's 4 sodium, 4 chlorine, 4 sodium, 4 chlorine, it's balanced. No, it's not. Because of the convention, if you can divide all the coefficients by the same number, in this case 2, you will get this one, and that's the correct balance equation. Because number 1, the coefficients, I can't divide all of them by the same number and get a whole number. All right, let's move on to number 2. Now, I'm going to help you out, maybe. You need to use my even odd trick here. Your turn. I'm going to work you hard today. All right, I assume everybody's done. Let's do it. Well, notice you have 2 oxygen here and 3 oxygen there. And therefore, we're in an even odd situation because there's no whole number I can multiply 2 times to get 3. And there's no whole number I can multiply 3 times to get 2. So what do? Well, what's the number they both go into an even a whole number of times? Well, the easiest way is 2 times 3 equals 6. So if I have 6 oxygen here, I need 3 times 2. If I have 6 oxygen here, I need 2 times 3. So now oxygen is balanced. Now notice 2 times 2, 4. Oh, oops, this should be, I made a mistake. Sorry. Correct that on your lab. Oops, I thought I corrected that. Bad, Dr. White. But anyways, we have 4 lithium, and now I have 4 lithium. One of these days, someone asked me after class about my thesis and why I have never opened it in the last many decades and never will. All right, let's look at number 6. And by the way, if I'm moving too quick off a balanced chemical equation, you want me to go back, say, please go back. Because remember, in my class, there's no such thing as a dumb question. Now, remember my advice. Do hydrogen, oxygen last. All right, your turn to do number 6, and I will. Am I being a nice guy on Friday? I'm sharing all this wonderful fun. Anybody keeping count how many times I say the word fun? Maybe I can get a Guinness Book of World Record on that too this semester. And when you're done, give me a thumbs up, or maybe I will do my polling. And don't forget, Monday is National Turn on Your Webcam Day for Dr. White, if you have one. That makes me very happy, which is a good thing in life for me and you too. All right, let me do this. How do you do it? Well, I'm going to follow my own advice. Do hydrogen, oxygen last. That means I have 5 carbons. Ooh, I only have 1. How do I get 5? I do that. So now I have 5 carbon. Next, well, I only have hydrogen and oxygen. I'll do 12 hydrogen. Well, I only have 2 here. How do I get that to 12? I can't change that number, but I can put a 6 in front of there. 6 times 2 is 12 hydrogen. And finally, I have 2 oxygen here, but on this side, and you count all the oxygen atoms in all the molecules on the product side, head of the arrow. 5 times 2 is 10 oxygen, plus 6 times 1 is 6 oxygen. And if I did my math correctly, if not, one of you I hope will correct me, you get 16. Well, this is 2. How do we get it to 16? Put an 8 there. And let's check. 5 carbon, 5 carbon, 12 hydrogen, 12 hydrogen, looking good. 16 oxygen, 16 oxygen, success. Oh, let's do another one. Remember, and do number 7. For those who finish early, please be patient. I'll try and give everybody time to finish. So finish. When I was young, my father challenged me. He used to say, intelligent people are never bored. And then he went and said, can you do this? One finger forward and the other one backward, and do them at the same time. When you're done with that, do them with your thumbs. So if you finish early, practice that, as long as you're not driving. All right, I think everybody's done, so I'm going to get to work. And if we look at this, I'm going to again follow my advice, do hydrogen and oxygen last. So I have aluminum one here, but I have two aluminum here. So that's easy. I'll put a two there. Now I have two aluminum. Hydrogen, well, I'm going to do that last. Sulfur, I have one sulfur here, but here I have one, but it's in a bracket and outside subscript to the right of the last bracket is 3, which tells me I have 3 sulfur. How do I get 3 sulfur here? Put a 3 there. So now I have 3 sulfur. If you look at all we have left are hydrogen and oxygen. So I'm going to do that. So I'll do how many hydrogen? 3 times 2 is 6 hydrogen. I've got 2 here. How do I make that 6? Put a 3 there. So 3 times 3 times 2 is 6 hydrogen. And finally, the only thing left to do is oxygen. 4 times 3, 12 oxygen. Come over here and we look at, oh, look, 4 times 3, 12 oxygen. I think I'm done. Let's check. 2 aluminum, 3 sulfur, 3 sulfur, 6 hydrogen. What did I put 10 for? That should be a 12. Somebody should have caught me. Wake up, people. When I make a mistake, let me know. 6 hydrogen, and 12 oxygen. That should be a 12. It is 12 oxygen. Success. Oh, let's do one more. We've already done number 9. I just realized, why don't we try number 12? Remember, someday when you have nothing better to do, try this one, doing oxygen or hydrogen first, and you'll find it's not that much fun. Do them last, and it is fun. One of the things I just realized with the poll is if somebody puts down no, they can't go back and change it. At least I don't think you can. So let's relaunch. All right, I think everybody's done, so I better get to work. If you're not, turn on your mic and say, stop, give me another 30 seconds. Or you can use the chat too privately. That's something I've never said before. I'm going to have to remind you of that. All right, let's do it. Do hydrogen, oxygen last, and I'm going to follow my own advice because I know it's good. So I have one sulfur here, but here I have 1 times 3, because it's in a bracket, 3 sulfur here. How do I make 3 sulfur? Change the coefficient. So now I have 3 sulfur. Hydrogen, oxygen, I'm going to wait till last. 1 boron here, but 2 here. So how do I make 2 boron? Put a 2 in front. Now, guess what? All I have left is hydrogen, oxygen. I'll do hydrogen first. Oxygen would work also. So how many hydrogen? 3 times 2, 6 hydrogen. And over here, it's in a bracket, and there's a 3 there, so that means there are 3, but there's a coefficient 2, so there's 6 hydrogen there. Add them up together, and we get 12 hydrogen. And now here we have 2. How do we get to 12? Put a 6 there. 6 times 2, 12 hydrogen. And all we have left is oxygen. So I have 3 times 4, which is 12 oxygen. Now I have oxygen in a bracket, and there's subscript 3, that's 3, but the coefficient is, guess what, 2 times 3 is 6 oxygen. Add them together. Remember, if I make a mistake, let me know, please. 18 oxygen. On this side, we have 4 times 3, 12 oxygen. And here we have 6 times 2, looking good. And that would be, oh, wait, 6 times 1. Somebody should have caught me on that. 6 times 1 is 6 oxygen. Add that up, 18 oxygen. I think we're done. Let's check. 3 sulfur, 2 boron, 2 boron, 12 hydrogen, 12 hydrogen, and 18 oxygen, 18 oxygen, success. And that's how you do balanced chemical equations. Now, remember the bicycle I told you about, story the first day of class, watching me do it, it's not that hard. If you haven't tried those on your own, you should before test 2 coming up soon. And I'll have at least 3, probably 4 3-point questions. That means 9 or 12 out of 100 points. So know how to balance chemical equations. And with that, guess what time it is? I bet you thought you'd go a whole class without me using this. Wrong. It's new chapter time. And this new chapter, what is it? It's gases. Now, gases play an important role in our daily life. Since the second instant you were born, unless you went scuba diving or were swimming under water in a swimming pool, you have been surrounded your whole life with gases. Yes, we call that air. You can't see it, but all around me, I can feel it when I go like this. And if you go outside and you feel the wind on you, that's molecules of gases hitting you. So gases are an important part of our life. And the stuff I'm talking about now, gases, will not be on test 2, but will be on test 3. And it's good that I'm getting ahead because come November, we're going to lose a lot of time because of Thanksgiving, Wednesday and that Friday. And also, I think a week from this Tuesday, there's an in-service day, no class for you guys, and we'll lose time there too. So it's good to be a little ahead with all the time we're going to lose. So let's talk about gases. Now, when we talk about gases, the important thing to remember is the kinetic theory, molecular theory of gases. Now, this is something you should be familiar with. And that is one, a gas consists of small particles, atoms or molecules that are moving randomly with very rapid velocities. Think of velocities as speed in a certain direction. That's a vector or velocity. I forgot all the vectors that work I had to do when I was an undergrad. But anyways, right now, all around you, there are little molecules, small molecules of gases hitting you. They're moving everywhere very quickly. Now, there's very small, almost non-existent attractive forces between the molecules or particles of gas, and they can be neglected when you're thinking about a gas. All right, the actual volume occupied by the gas molecules is extremely small compared to the volume that the gas occupies. And what does that mean? Unlike a liquid or a solid, let's say these were two gas molecules. In a liquid, they're close. In a solid, they're real close. In a gas, they're far, far apart. I like that expensive visual. But anyways, in gases, like right around you and me right now, say oxygen, nitrogen molecules are very far apart. The bulk of a volume of a gas is this empty space. Now, the average kinetic energy, which means the motion of a gas, is proportional to the Kelvin temperature. In gases, we don't use Celsius or Fahrenheit, we use Kelvin. And you learned already how to go from Celsius to Kelvin. And the higher the Kelvin temperature, the more kinetic energy the gas molecules have, meaning they're moving much faster. And gas particles are in constant motion. And they're usually moving in a straight path unless they collide with something. I guess the best way to think of gas molecules in the air around you are like billiard balls. If you ever played billiard, the billiard ball, when you hit it right, goes straight until it hits something, then it goes bang, bang, bang. I like that bang, bang. But anyways, Dr. White was never a good pool or billiard player. That's not my cup of tea. This is my cup of tea. Oh, awful humor Friday. Hope I never say that again, maybe. But anyways, that's the kinetic theory of gases. All right, let's talk about key properties of gases. And one of them is pressure. In case you don't know what pressure is, I'll be teaching you what pressure is. Another one is volume. What's the volume of the gas? Another thing is the temperature of the gas. And finally, how much do you have, the amount? And that's usually grams, and you convert that to moles, and you know how to do that. Now, when we talk about these things, why am I learning about gases? Well, one, it's keeping you alive. The air you're breathing is a gas. For those who've ever ridden in a car, the tires are filled with a gas, air or nitrogen, to keep them inflated. And let's talk about pressure, because I'll teach you some chapter about the importance of the pressure of your car tires. Now, switches off for this slide in the sense that what is gas pressure? And I'll never ask you to use this formula, but so you understand what is pressure. And pressure is the force applied per unit area. That's the total force on the surface divided by the area of that surface, this equation. But we'll never use that in calculations. What you will do is get a measurement. Now, one of the things that's interesting, from the instant you were born, I don't know if you remember when you were born, I sure don't. From the instant you were born, molecules have been pushing on your skin, always. And guess what? You don't feel it unless it's the wind. Why? Because it's been there all your life. But they're pushing on your skin right now. We call that pressure. And how do we measure that pressure? With a device most of you are familiar with. And that's a barometer. And a barometer is a device that's used to measure atmospheric pressure. And that's the pressure of the gas around us right now. And this is a very important number, the atmospheric pressure, and barometers are. Now, what units are pressure measured in? The most important ones for this one, by the way, oops, wrong thing. If I had a knob that only went up to 10, to turn up 10, I just turned it up to 30 or 40. Know this. All right, one way of measuring pressure in chemistry is by millimeters of mercury. And millimeters is a distance. Why millimeters of mercury? And I should also note that by definition, 1 millimeter mercury is equal to 1 torr. All right, thumbs up, people. Let's see if I can get this fuller screen. Does everybody see on your screen now where it says vacuum, glass tube, and mercury? Maybe not.
Yeah.
You see it?
Yeah.
All right, thank you. All right, this is the original barometer. And who did a lot of work with this and helped develop it? An Italian scientist called Torricelli. And that's where torr, 1 millimeter mercury, is equal to 1 torr. It's named as his honor. Now, if you take a empty tube that has a vacuum in it and you put it in a dish of mercury right here, the atmospheric pressure pushes down the pressure of the gas surrounding us. And that pushes the mercury up to 2. And if you measure the distance from the top of the level of the pool of mercury in the dish to the top of the mercury in the tube, you can get a length. In this case, the one they're showing you is 760 millimeters of mercury. And that's the original barometers. Now we have electronic sensors in other ways. Why? Because mercury is highly poisonous. I remember when I was an undergrad, we had these type, it wasn't open, it was sealed, but still somewhat sealed, these type of barometers in our lab. In fact, even when I started teaching a number of decades ago, wow, that long, we had them in a lab at Elgin Community College. I think we had some at COD too, but mercury is so poisonous, we got rid of that. Now, when the atmosphere pushes down, it pushes it up, the tube and we measure that distance. And now most of you are familiar with these type of barometers. They have a mechanism inside that will measure pressure. So a barometer will measure pressure. It's so important. It's a major part of weather forecasting. By the way, I'm not a weatherman, but it's time. I've got a minute. For those of you who don't know, George Carlin was one of the greatest comedians around. There are a couple others I could mention. And he did a funny skit called the Hippy Dippy Weatherman. And I don't know if that's on YouTube. I think everything's on YouTube except my high school and college graduation. Maybe when I was born too, that's not there. But let's check real quick. And lo and behold, here it is. I'm going to let you go listen to it. Trust me, you'll like it. But anyways, the atmospheric pressure plays an important role in our daily life. One is weather, other things too. And if I look at the clock, oh, I got another minute. So let me take you somewhere else on the internet. If you don't know about this, this is my favorite site for the weather. I no longer listen to the news on TV. Why? To get the weather, I can just go online. And this is Weather Underground. And I have it for where I live in Schaumburg. And if we scroll down, you'll see right here pressure. And this is the barometric pressure. Instead of millimeters, since we're in the United States, they have inches. And there are various ways of measuring pressure, which we'll talk about next week. And with that, I think I'm done for today and the week. All right, listen carefully. If you haven't handed in past labs that I don't have a grade in, other than the last lab that you just did, number 5, which I'll post soon, today or tomorrow, make sure by next Tuesday, if the link isn't open on Blackboard, email it to me. Also, next Tuesday, we will, thank you, Ruben. We will go through chapter 5, part 1, practice problems, the 3-part and other stuff you should practice. And with that, I'm going to wish you a great rest of the day and weekend and say, gang gesund, be healthy. Don't forget to wear your mask, get your flu shot. If you haven't gotten a flu shot, you don't want to get a flu during the pandemic. I got my flu shot on Tuesday. And if you're not vaccinated for COVID-19, please get vaccinated as soon as possible. With that, once more, bye now, gang gesund. Have a great weekend.